Show captions so people can, because I'm sure people are going to have the same question.
Okay.
I just, I would bet money on that. Okay. So for number 21, for example,
Okay.
triangles and isosceles triangles. Whoops. Let me get my annotation tool out here, whiteboard. Why is it not showing me? Okay, there it is. Okay, here we go. So we have the set T triangles, right?
Mm-hmm.
And then we have the set U.
I.
Is it I? Okay.
I
I is isosceles triangles. So it's pretty direct from the language, even if you're not sure what an isosceles triangle is just yet, that an isosceles triangle is a triangle.
Yeah.
Right. So in this case, isosceles triangles overlap with triangles. Now the question is every isosceles triangle
a triangle?
A triangle, yes. Is every triangle isosceles? No, because isosceles triangles are triangles that have at least two sides the same length.
Got it.
At least two sides the same length. So if you have two sides the same length, you're isosceles. If you have all three sides the same length, you're also isosceles. Okay, so by this definition, equilateral triangles, and those are the ones that have all three sides the same, equilateral triangles that have all three sides the same length are also isosceles. Okay. Isosceles. So in terms of the Venn diagram, if we draw a Venn diagram, we're going to draw a rectangle, right? And obviously these overlap each other. So you have a circle, right? We'll call it high. Now, every isosceles triangle is also a triangle. So if this is my set I, right, then there's T, and T, the big one, is a bigger set than I is. But T includes things like equilateral triangles and scalene triangles and whatever. So isosceles triangles here is what we call a subset of triangles, I. So we would say that I is a subset of T.
Okay.
Okay. Now, it doesn't matter what the other sets do. We're just concerned about T and I. Okay. So in terms of what else? I know they ask us a bunch of questions. Let's go back and look.
Yeah, so it does start off with the P equals the all polygons as the universe. So that just means that is the biggest like the biggest circle, I guess.
P is all okay. Well, if it's the universe, then what they're talking about here, when you draw a Venn diagram, the universe is your rectangle out here. So it includes it includes everything, all the circles that you draw,
Uh-huh.
and it also includes everything that's outside of it. So there are polygons, right,
Mhm.
that are not triangles.
Yes.
Things like squares and parallelograms and rectangles, all of that.
Mm-hmm.
For simplicities, I'm not drawing all of those. I just drew the two they gave me, but there are other polygons in this universe.
Okay.
The universe, when you draw a Venn diagram, the universe refers to everything in the rectangle.
Okay.
So this is my universe. So if I drew something like the set T, right,
Mm-hmm.
out here, and then I drew something that didn't have any overlap, like let's say rectangles, right? So let's call it R just for the sake of, so the set triangles and the set rectangles, these are what we call disjoint sets. They don't have common elements, right? But they're all part of the universe of polygons, which I can call P if I want to, right?
Okay.
Something like that. That's what we're after.
Got it.
Yeah. Okay.
Okay.
So let's go back to this and see what else. Do they ask us anything else? Represent the relation. Okay, describe a subset relationship. We did that. Are the sets described disjoint or equivalent? Okay, so for 21, we described the subset relationship. I is a subset of T, right?
Mm-hmm.
And are the sets described disjoint? No, they overlap each other, right?
Mm-hmm.
There are isosceles triangles that are triangles, so they're not disjoint sets.
Okay.
And do the sets intersect? Yes.
Got it.
Yes, they intersect with when that, and that sometimes is tricky for students because the whole set is inside,
Yeah.
right? And yet, so it's not just part of it that intersects. Now, in this case, how about 23?
Mm-hmm.
Acute triangles and scalene triangles. Okay, what do you think here?
So yeah, like on that one, so I have like the acute triangles, or they're kind of overlapping the scaling because not all acutes are scaling.
Okay, so if they're acute,
or have to be.
well, okay, so you could have an acute triangle
Mm-hmm.
that an acute triangle has to be a triangle where the angles are less than 90 degrees,
Yes.
right?
Mhm.
So, and remember that the angles have, so scalene has to do not with the angles, but the length,
Mhm.
right? So if, for example, if I have an equilateral triangle,
Mhm.
that's acute, right? Because all the angles are less than 90 degrees,
Uh-huh.
right?
Yeah.
But it's not scalene, right? But if I had a triangle that was, let's do this. If I had a triangle, let me see if I don't like the fact that Zoom doesn't give me acute triangles. I'm gonna have to improvise. They don't give me that, but it's okay. They give me a straight line. I can do this. So
Yeah,
this
that works.
is a right triangle, okay? Which you may or may not be familiar with right now. We haven't covered it in this class, but sometimes people have seen it before. Means that it's 90 degrees on this side, okay?
Yeah.
This angle. Now, these two angles, I'm not quibbling about right now. But if I make this angle up here 60 degrees, and I make this angle down here 30 degrees, and remember this square corner means this is 90 degrees, then I've just created a right triangle that happens to be scalene.
Mhm.
Now, how do I know that? Because these angles are all different. So something you'll learn later is that the longest side of a triangle is opposite the biggest angle that you have.
Okay.
So 90 degrees is the biggest angle. This is the longest side of the triangle. This 30-degree angle is the smallest angle. It's opposite the shortest side of the triangle. And 60 is somewhere in the middle of that. So this would be a scalene triangle
Mhm.
that's not acute. This is a
Degrees.
right scalene, or actually we usually put the word scalene first. So we usually call it a scalene right triangle. So there are scalene triangles that are not acute. Okay. If I draw, as I mentioned earlier, if I were to draw, and I shall see if I can do this and look somewhat believable. Well, that's not too bad. Let's assume, let's humor me and assume that this is 60 degrees.
Okay.
This one is 60 degrees. And this one is 60 degrees, which would mean that all of my sides are equal to each other. So what I would be saying in that case is that this side is the same length as this side, which is the same length as this side, which is an equilateral triangle. That's not scalene, but it is acute, right?
Yes.
So this is an acute triangle. This is an acute triangle that is not scalene. So you can have that. You can also have a right triangle where these angles match each other. They're 45 degrees each. So yeah, you can have different kinds of scalene triangles. So is every scalene triangle acute? No. But every acute triangle may not be scalene either, but they are part of triangles. So if you want to think of it like, and I'll draw the Venn part of this in a minute, but you got the big triangle circle here, right? So this is your big triangle circle, right? And then we've got, oops, I didn't mean to put that up there. You have, this is your big triangle circle out here. And then you've got T, and then you've got the scalene triangles that are part of this. How this would look is something like this. So you've got some scalene triangles in here, right? Not all of them, but let's say that this is the set of scalene triangles here. Call it S, right? We've got acute triangles that could be scalene. You see what I mean? So you have some, so scalene triangles are a subset of triangles, and you might have a scalene right triangle, right? But you could have an acute triangle that's not scalene. So that's how that fits. So if I go back here and I say, okay, what's going on with this? So, an acute triangle could be scalene if it was an acute right triangle, right?
Mhm.
An acute right triangle could be scaling. So it's possible that an acute triangle could be scaling, but it doesn't have to be. So
Yeah.
if I were to draw this, it would be something like, I just put the triangle in there to kind of help you, but the acute circle would be something where it would be attached over here somehow. And it doesn't matter where you put this overlap as long as the overlap shows
Got it.
to some degree. So this would be your acute circle, right? Because there's lots of acute triangles that aren't scalene. So this would be your A here. You see? So A is a subset of S, and S is a subset of T, right? And
Yeah.
none of those sets are disjoint, and they're all part of the universe of polygons. So if I wanted to, I could draw, let me go ahead and draw a Venn diagram, because I drew the circles and didn't draw a Venn for it. But let me draw a Venn diagram around this. And it doesn't have to be this big either. I'm just trying to make it somewhat easy
Mhm.
for you to see it.
To visualize. Got it.
So yeah, don't feel obligated to make it this large. It doesn't have to be. But sometimes when you make the tiniest Venn diagram and try to explain it, then it doesn't work well. So this is your universe P for polygons again. And again, there's other polygons out here.
Mhm.
You don't have to name those other sets. They just want the
What they're asking for. pretty much.
relation. Yeah. So this is not a huge part of this. I can tell you that Professor Nickdell is more concerned with you understanding which groups of shapes relate to which other groups of shapes than she is how well you can draw the Venn diagram.
Okay.
So
Got it.
if you understand that some scalene triangles are right triangles, or some all scalene triangles or triangles, things like that, those are things you should understand. Okay.
Okay.
So how about 25? Hexagons and octagons.
Okay.
That one's a little easier, actually.
Yeah, that one I figured is just kind of they're both different, so they would not even overlap,
Right,
but they are both polygons.
right. So they would both be in the universe of polygons, right? But they would be what we call disjoint sets. So the hexagons wouldn't overlap the octagons at all. Hexagons have 6 sides and octagons have 8, so
Yeah.
they don't overlap.
Yeah. Okay. Yeah, I think I was just pretty much wanted to make sure I was understanding correctly. I mean, I do understand Venn diagrams, and I do understand what the triangles and the things that are being asked. I just wanted to make sure.
No, I can see why, and these questions are a little bit odd in that way.
And I
So
wasn't sure, like, if I have to explain, like how it says, describe the subset relationship, or do.
that just means, that's just a fancy way of saying, do you know what a subset means? Do you remember?
I mean, it's like a category underneath some, like a specific.
Right. So for example, is there any hexagon that's an octagon? No.
No.
Right? Is there any octagon that's a hexagon? No. So in this case, you would say there is no subset relationship between H and O, right?
Uh-huh.
But for example, in 21, isosceles triangles, is a subset of T.
Got it.
Right?
Mhm.
Isosceles triangles, is a subset. It's inside the bigger set T. That's all it means.
Okay.
That's all it's talking about. So when it says describe the subset relationship, tell me whether there is one and which set is a subset of the other one. Does that make sense?
Yeah. I mean, yeah, it makes sense now.
Yeah, no, reading it, I agree. Reading those directions is a bit of that's a brain teaser in and of itself. Anything else I can help you with today?
I think that'll be it for now. I did kind of, I mean, luckily everything else seemed pretty easy to me
Yeah.
this time. I know the last few units, I forgot what unit it was. I should have got on here and talked to you about it, but anywho, I think as I got into these next units, 2 and unit
Mm-hmm.
3, I went back and I was like, oh, okay. So it just, I don't know, some of this newer stuff helped me understand more of the
Is
earth.
helping. Yeah, that's fine.
So,
Don't hesitate. I'm going to tell you the same thing that I told another student last week. If for some reason your schedule doesn't work or something like that, don't hesitate to Canvas message me or Pronto message me or Professor Nick Dell. My suggestion is that if you email or you message one of us, that you message both of us so we can respond to you.
okay, got it.
So if you're having problems, and you're welcome to say, yeah, I'm working on problem, whatever, or can you please explain this? Because this is,
Okay.
let us know, because we actually haven't had too much engagement from this class yet. And I don't know if that's because the material is relatively easy so far, or
Or because nobody's just coming.
if nobody can come at that time, because there's things that we can do if that's the case.
Got it.
I mean, so let us